Okay, so this is gas stoichiometry, and where we're going to start is you have to recall from your gas unit the molar volume at SATP, which is standard ambient temperature and pressure, that the molar volume is 24.8 liters per mole, and at standard temperature and pressure it's 22.4 liters per mole. Also, the ideal gas law, which is PV equals nRT, P meaning pressure, which always has to be in units of kPa, V meaning volume, which always has to be in units of liters, N meaning number of moles, always has to be in the unit of moles, T, which is temperature, always has to be in the unit of Kelvin, and then R, which is our ideal gas constant, which is 8.314 kPa times L over mole times K. And then also the law of combining volumes, which is when gases react together to form other gases, the volume of the gases show simple whole number ratios to each other, assuming same temperature and pressure. So an example of that is, so if I have hydrogen gas and chlorine gas, that results in hydrogen chloride. And I have 1 liter of hydrogen gas, and I want to find out how many liters of hydrogen chloride I have. I just use the molar ratio to convert the volumes. So it would also be the ratio of volumes. So 1 liter of hydrogen, for every 1 liter, we have 2 liters of HCl. So then that would give us 2 liters of HCl. So those are the main things that you need to remember for this unit, and then I'll do some example problems. So it's really important also, in every stoichiometry question, the first thing that you're going to do is write out a chemical equation. So number 1, we have 300 grams of propane. Burns in a gas barbecue. What volume of oxygen is required at SATP? So first things that we're going to notice is that we have 300 grams, we're looking for the volume, and they also give us SATP, which means that we have a specific set of conditions of temperature and pressure. And so the first thing that we need to do is write out a chemical equation. So propane has the chemical formula C3H8 plus oxygen. And notice that this is a combustion reaction, so it results in carbon dioxide and H2O. And then we need to balance the chemical equation. So we'll start with carbon. We have 3 carbons here, so we need 3 here, sorry. So that gives us 3. We have 8 hydrogens here, so we need 8 here, but we already have 2. So when we put a 4 in front, 4 times 2 equals 8, so now we have 4 hydrogens. And now we have 2 oxygens here, but we need 6 plus 4, which is 10, so we put 5 there, and then you have your balanced chemical equation. Okay, so now we have 300 grams of propane, and we need to find the amount of oxygen in liters. So Also notice here that all of the reactants and products are all gases. Okay, so in this question we need to find the number of moles of propane. So to do that, we start with the amount that we have, which is 300 grams, and then we find the molar mass, which is 44.11 grams for every 1 mole. And then to convert that to